Shut up, y'all. Okay, you didn't even have 21 problems. Shh, Charlie. Number 4 on the back. All right, so I went through and gave you the domain of each of these functions, right? So f of x, the domain, so this is x squared minus 5x. And what's the domain here? Negative infinity to infinity. And then g of x is a linear function. So what's the domain? And then, yeah. What you don't include. So what's the domain of h of x? There you go. It can't be 0, right? So I'm negative infinity to 0, u 0 to infinity. All right, so number 4. 4. Was there a particular one on 4, or all of them, or? Yeah. All right, 4a is g of f of x. So that's g of f of x. So sometimes I will come in here and say, okay, well, this is g of, what is f of x? F of x is x squared minus 5x. So everywhere there's an x in g, I'm replacing it with x squared minus 5x, yes? Here's g, so it's 3. It's not x anymore, it's x squared minus 5x plus 1. So 3x squared minus 15x plus 1, and there's nothing else I can do with that, so I can just stop. Now the domain, I have to look at the domain of each individual one. There's no restriction on either domain, right? And whenever I put them together, there's no fraction and there's no radical. So there are no restrictions on this domain. So the ones that have like a number and the f of that thing, like for number 60, like 60, you put the number in for like the second letter. You put, so for that one, I'd put negative 6 in for every x in h. And then I'd get a value, and then that value I'd put for every x in g. That's right. Wait, why didn't you put a 3x? Because it's not x anymore. It's, instead of being x, it's x squared minus 5x. Right, Charlie? So I'll go to g, and I replace that x with x squared minus 5x. My calculus class came up with a good plan for y'all. Did you? How did y'all hear it? Oh. What'd she say? Well, she said anyone with a below a C average in the class, this is not just her, this is what they said. Anyone below a C average in the class has to put their phone up until their average comes above. Right. That's what I said. I said if you fail the test, you have to give your phone up until the next unit. But then 4B. H of G of X. So I'm going to do H of G of X. So this time, I'm plugging G in to H. So G is 3x plus 1, right? So this time I look at the H equation. Remember, H of X is x minus 1 over x. So everywhere there's an x, I'm replacing it with 3x plus 1. So I have 3x plus 1 minus 1 over 3x plus 1. Uh-oh. Does that make sense? Yeah. Now simplify it. The ones cancel. 3x over 3x plus 1. Now I have to think about the combined domain because this is the new part. This is the little bit harder part. Okay, so let's think about it. For h of x, I know that x can't be 0, right? For g of x, there are no restrictions, right? Now, when I put them together, are there any new restrictions? Yes. X can't be what? Negative 1/3. The bottom can't be 0. Yes, yes, yes. So now there are two things that I have to leave out of my domain, because if it was left out of one, it has to be left out of the combined. So yes, those are the two that I'm leaving out. So now the question is, how do I write that in interval notation? Negative infinity, that's right. Negative 1/3, pick back up on the other side of negative 1/3. Go until you hit 0 and stop. And then 0 to infinity. Remember, back-to-back parentheses leave out just one number. So this is leaving out negative 1/3, and this is leaving out 0. That leaves out 2. Okay, where did I lose you?
A little bit.
Do you understand why I left those two values out? All right, yeah, Corey. Say again. Okay, so listen, guys, listen, because y'all are asking lots of questions, but you can't understand if you don't pay attention. 0 is left out from h of x in the very beginning, right? If it's left out of one of the original functions, then I have to leave it out of the combined function as well. So I look at each one individually first, leave out anything I have to leave out, and then I look overall at the combined one and say, okay, is there anything else I need to leave out? In this case, there was an additional something that I had to leave out. Make sense? Okay, yes, Charlie. Thursday. Then we'll have it Tuesday if it's. All right, what else on your homework? B and C on which number? 5. Number 5. So let me write the functions here. Guys, it's hard to talk over you. What is it? 5. The nice thing about number 5 is that none of these have any restrictions. Why do none of these have any restrictions, but yet I see a radical in here? It's a cubed root, right? I can put a negative under there because that doesn't matter. I can take the cubed root of a negative number. I can't take the square root of or the fourth root or the sixth root, right? Because then I'm in imaginary land, yes? Okay. So no restriction so far. So the only restriction I'm going to need to worry about is if there's some kind of restriction when I combine them. Okay. All right. So 5. Which one did you say? Anyone? B and C. Part B says h of g of x, which is the same thing as h of g of x, which is h of the cubed root of 4x. So everywhere I see an x and h, I'm replacing it with cubed root of x. Excuse me. So I go to h. Here's h. So it's 2. That's not x anymore. Instead, it's cubed root of 4x minus 5. Hopefully you can still see this function, 2x minus 5, which is what I had right up here. All right, and then I need the combined domain. Well, if nothing was left out of either one of the two, of h or g, and I put them together and I don't have an even radical and I don't have a fraction, and nothing's left out of the combined one, what's the domain? Negative infinity. There's nothing else you can do with that one. Negative infinity, infinity, yep. See? G of f of x. You're going to really have to be able to compose functions well for what we're doing today. What is f? X cubed plus 6. So now I'm taking this function and I'm plugging in 4 times x cubed plus 6. I would probably stop right there. If you want to make this the cubed root of 4x cubed plus 24, you can. You don't have to. It's really not doing anything to do that. You can't cross these out because you're adding in here. So you just leave it. Domain, again, there's no restrictions on any of them individually. Combined, I don't have an even root, so the combined domain is just negative infinity to infinity. That is C. There's not a D on 5. Yeah. You don't even have to do domain on those. Whenever you're just plugging in a number, you're just finding the corresponding Y value, so you don't have to, yeah, there won't be a domain on that one. I'll do that one. Did you have another question, Sonny? Okay. All right, let's look at 7 and 8. 7 and 8's a little bit harder because you have to kind of think backwards on it. So they tell you that h of x, 3x minus 1q, h of x is two functions that are already composed. This is number 7. What do you think f and what do you think g is? F is 2x to the third and g is what? Would that work? Yes. There's not really, I mean, you really just have to kind of look at it and see that you've got a function within another function. And so whenever you do that, yeah, there's not really anything to, and it's really hard to even explain. You just have to understand compositions forward well enough to be able to see that is what it is. So h of x is f of g of x. What'd you put for g of x? What's your inside function that you plugged in? So if this was my function, right? Or that was what I plugged in, then what did you start with? There are different answers you could have had for that. You could have set your original function to -3 over x or very, It could be. It'll be easy though. What? 6 what? See? Yes. All right, number 6. F of x is x squared minus 4x. Charlie, I'm so impressed you're paying attention. G of x, 2 minus 3x. I've actually seen the whites of your eyes today. What's domain on F? What's the domain on G? Whoops. What's the domain on H? Y. And then what? U. It's a fraction and the bottom can't be 0, right? Okay. Yeah, so it depends on what's in the bottom though, right? If it was 3 over x plus 1, what can x not be? Right. The bottom can't be 0. Which one? Negative infinity to -1, u -1 to infinity. Just leaving out that -1. Which 6 did you say C? Oh, we didn't even have to have the domain on this one. G of h of 6, -6. The first thing I'm going to do is find h of -6. 3 over -6, which is -2. So I'm going to say, oh, well, h of -6 is -2. So what is g of -2? 2 minus 3 times -2. 8. That makes sense? No, I can tell what you're looking at. H of negative 6. I don't know. Great day. So 2 minus negative 3 over 2, which will be 4, which will be, golly, 7 over 2. Yeah, sorry. You don't understand which part. Because I forgot to, I simplified this as 2 instead of 1/2, like a dodo. So this is 3 times negative 1/2. Yes. That's okay. I want to make sure you're with us before we move to the next one. What else on your homework? 6D. So same functions here, but I'm doing h of f of 2. So I'm going to find f of 2 first. F of 2 is 2 squared minus 4 times 2, which is 4 minus 8, which is negative 4. So now I'm doing h of negative 4, which is 3 over negative 4. What else? Yeah. Which one's you saying? 3a. Number 3. And again, look at these individual domains. For this one, x has got to be greater than or equal to 7. For g of x, x has got to be bigger than or equal to 0, right? All right, so for part A, I'm asked to do f of x plus g of x. And if you can't do it, you just write it. So don't, several of you tried to put these under the same radical, and you can't do that. I can't add radicals unless they're like radicals, and I definitely can't put them. I can do this, but I can never do this. backwards or forwards. Okay, so be very careful. So I just leave it written just like that, and then I work on the domain. Okay, and since I'm only adding, I'm just looking at the domain individually, so I have to picture this kind of on a number line. Here's 0 and here's 7. If this one's got to be bigger than 0, and this one's got to be bigger than 7, and I only want what they share, right? So this one is all of this. This one is all of this. Where do I have green and purple? At 7 and bigger, right? So the domain on this would be from 7 to infinity. Does that make sense? Sullivan, are you good? Where are you not good? This number 3, yeah. B asks us to subtract. So again, it's the same scenario here. The only difference is there's a subtraction in the middle instead of an addition. Domain is the same. Everything's the same. Is it f minus g or g minus? Oh, it's g. Okay, then yeah, g of x minus f. Just switch them around. Square root of 2x minus the square root of x minus 7. Domain is still the same. Yeah. Right, Charlie? Right. Don't let them peer pressure you, because they're not going to peer pressure your grade. All right, C. Right here in 7 to infinity, yeah. Where are you getting they don't, right. Now C is going to have a little different domain, right? Because C is multiplying, right, Charlie? Can I multiply these under the same radical? Put your phone down. Smile for your mama. I'm going to Facebook message his mama with that. Why? I don't want her to fuss at me for you not doing well. Okay, now say again. Okay, so this one gets a little bit harder, right? I got 2x squared minus 14x has got to be greater than or equal to 0 now, right? Let's think about this like x does equal 0, and it equals 0 in 2 places. What 2 places does it equal 0? Where does this equal 0? Right? This goes to 0, and this goes to 0. If 2x equals 0, then x equals 0. If x minus 7 equals 0, that's what I'm working on, is the domain. I factored a 2x out of this. Look, that's what I started with. because I'm trying to solve this inequality. So if I need to solve this inequality, I need to know where it crosses, because I'm thinking this is a parabola that opens up, right? I need to know when it's bigger than 0, so I need to know these areas above the x-axis. So to know those areas, I need to know where it's actually crossing. Yeah. So now we're not, because remember whenever we solve quadratics, we don't solve them that way. We solve quadratics by factoring or completing the square or doing any of those things, okay? So what I know now is I know that I have this parabola that crosses the x-axis at 0. And this is kind of new, y'all, so if you don't remember how to do this, this will probably come up again. It's crossing the x-axis at 0 and 7, right? I know it opens up because it's a positive leading coefficient, right? I don't know what else it's doing, but it's doing that. Look at what I need to know. I need to know where is the parabola bigger than 0? Well, it's bigger than 0 here. So when x is smaller than 0 or when x is bigger than 7, right? But remember, I'm talking about a combined domain here. So I got to go back up. Already I know x has got to be bigger than 7 here, yes? So this one's not even going to apply because that one keeps it from happening anyway. So it's 7 to infinity. For this one, you might not have what? Because you have to look at the combined, right? What if this had been this, and this had gone this way, and your positive only lies between 0 and 7? Your domain would literally consist of one number, and that's 7. Because individually, your domain was from 7 to infinity. This is not the square root of this. This is, I'm trying to solve this for 0. It's a different scenario. This is, do y'all remember doing these in Algebra 2? Because y'all hated it, where you had to test the intervals and see. Same difference too. All right, let's look at D because D is a little bit different. D takes g of x and divides it by f of x, right? So g, which is the square root of 2x, divided by only one thing changes here. Do you see what it is? You can't equal 7. That's exactly right. Because if I equal 7, it's going to put me a 0 on the bottom. It's okay to have a 0 under the radical or inside the radical, but it's not okay to have a 0 in the bottom of the fraction. So my domain this time is going to be 7 to infinity with a parenthesis instead of a bracket. That's the only difference there. Ray, we're starting. What? We're going to go through this. I'm just going to hit on the high points of this. I'm not going to go all into some of this. The high points. The high points. No, you've actually done it before. Per Um, oh, perfect. I'm sorry. Great day. Um, I am sure that no one would get that confused. Tell me what an inverse relation is. Okay, it sounds like opposite. Tell me in terms of graphically what's happening. What flips? Flip what? What part of the graph? No. Wasn't he? Oh my gosh. Switch X and Y. Okay, so if I start, let's just start really basic. By the way, we denote this if f of x is the function, then the inverse function, we put a little -1. Do y'all remember this now? It's an exponent. This means inverse of f. Right, Charlie? Put your phone up. I'm fixing to make you put it in a pocket. If this is a relation, right? My x and my y, the inverse of this would be literally just switch the x and the y values. Now, what makes something a function? Charlie, I'm impressed. The vertical line test, which tells us that every input has one and only one output, right? How could I test to see if the inverse is going to be a function? What if I don't have a graph? What if I only have a graph of the function itself and not its inverse? In other words, this is a function because it passes the vertical line test. If I want to know without actually graphing it, is the inverse a function, then I do the horizontal line test. In this case, it would not be, the inverse is not a function because it fails the horizontal line test. So while it's a function, its inverse is not. Do y'all remember this? Talking too fast. What do you call a function that is a function as well as its inverse is a function? It's a special kind of function. Do you remember what it's called? A double function. Anybody? It's called one-to-one. Okay. One-to-one means that it is a function and its inverse is a function. So can you think of one that would be a function as well as its inverse be a function? Can you think of a one-to-one function? An x. What do you mean just x? You mean y equals x? So you mean this? Yes. Can you think of another one? Y equals x squared would look like that. Square root? Yes. Cube root would be, yes. That way, or that's a negative cube root and a positive cube root. Actually, that's cube, not cube root. Cube root looks like that. Also still one-to-one. Okay. Do you see the point we're getting to here? One-to-one? Yes, no, maybe so. Everybody okay? What makes it a function? What makes its inverse a function? What it means if they're both functions. So what we're going to focus on today is finding the function algebraically and verifying that they are functions. So, algebraically, how do I find an inverse? If I told you that f of x was negative square root of x plus 2 minus 7, and I said, what is the inverse? Put y in where? So do this. So just do this. I'm just doing what y'all tell me to do. Switch x and y. I don't see a y. F of x is y. This is the same thing as y equals negative square root of x plus 2 minus 7. You would be surprised. Now what? Now what? Don't follow him up. Don't follow him up. I'm going to now solve this for y. I'm going to add 7 to both sides. What do I do now? Negative 1, that's exactly right. So negative x plus 7. What now? Square both of them. What happens when you square a No, I'm not. I think I'm just going to write it as that. What happens when you square a negative? What happens when you square a negative? Yeah. When you square a negative, it becomes positive. Actually, we got to start. Yes or no? I'm going to assume yes. Thank you. All right, let's talk about the hard part. Yes. Find it. Now we have to verify. How do you verify? This is the part y'all hate. No. We got to show it both, forwards and backwards. Remember doing this? Everything will cancel out but the x, but I have to show it. Yes. Yes. All right, let me show you an example. Yes, y'all ready? Okay, so this is an example. If I tell you that these two are inverses of each other, and I ask you to algebraically verify. I've got to show two things. You do remember this? I've got to do f of g of x, and I have to do g of f of x. What we just did, that's exactly right. So I'm going to plug 2x plus 7 into f. What's 7 minus 7? Charlie, stop worrying about your grades. 0. Those cancel. So it comes down to x. If you don't get x, they are not inverses. And you have to get it backwards and forwards, okay? So be careful. So now going the other way. Give me a slow down. Say again. Yep. What? Not every time. Mathematically. Anna, are you caught up with me? Are you caught up? Okay. All right, Charlie. I look at G. 2. It's not x anymore. It's x minus 7 over 2 plus 7. Yes? What cancels first? The 2's. And then it's just x. If I were to graph both of these, what I should see is that the x and y axis have switched places whenever I graph them. You will have a few you have to graph. Yes. Yes. We literally just took a break. I'm going to graph f first just to show you. I just wrote it, as slope-intercept form instead. So negative 3.5, 1, 2, 3.5, and then up 1 over 1, 2. This is f of x, yes? And then the inverse of that, 2x plus 7, it's crossing. I'm going to go down and backwards this way. If this flipped around and the x-axis became the y-axis and vice versa, it would be the same graph. Does that make sense?